All right, everybody, let's look at lesson 4A, which is voltaic cells. So, what is electricity and how is it formed? In a spontaneous redox reaction, electrons are transferred and energy is released. This energy can be used to do work in a voltaic cell. Voltaic cells are cells that have batteries in them. So, what happens is you have a spontaneous redox reaction, which means it converts chemical energy into electrical energy. And that allows for the electrons to flow, and they're going to produce electricity. So how does a voltaic cell work? Electrons flow spontaneously, meaning on their own, they don't need extra help, from the anode, which is a more active metal, to the cathode, which is a less active metal. The anode is where your negative electrode, where oxidation or your loss of electrons is going to occur. The cathode is the positive electrode, and that's where reduction or the gaining of your electrons is going to occur. So, an easy way to figure out what's happening where is to remember this little saying, an-ox. So, anode is where oxidation happens, and red-cat, reduction is at the cathode. So let's look at an example. Since Zn is higher on table J, so electrons will flow from Zn to copper in a voltaic cell. So Zn is the anode because it is being oxidized, and Cu is the cathode because it's being reduced. So your electrons are going to flow in this direction from the anode to the cathode. There are parts to a voltaic cell. The first thing you have to have is two half cells. One cell is where your oxidation is going to happen, and the other one's where your reduction is going to happen. The electrodes are the actual pieces where you're going to have the oxidation and the reduction. So a metal piece or something along those lines. You're going to have a wire that's going to connect those electrodes, and that's what's going to allow for the electrons to flow. You're going to have a salt bridge, which is going to allow for ions to flow and prevent the buildup of charge. And this will allow it to be electrically neutral. So this is your salt bridge is where your spectator ions are going to flow back and forth between the two half cells. And you're going to have a voltmeter. That voltmeter is going to measure how much electric current is going through your wire from one cell to the next. So then how do you label what a voltaic cell is? First, you need to determine which electrode is the anode and which is the cathode. Then you have to identify where the oxidation and reduction is taking place, and then you have to figure out what direction your electrons are flowing in. So remember, red cat, so reduction happens at the cathode, so that's going to be two pieces of the voltaic cell that are easy for you to label, and an-ox. At the anode, oxidation is happening. So, you can use table J in your reference packet to determine the flow of electrons. So, the more active metal is what is oxidized. We've already talked about this. So, electrons will flow from high to low. So, the more active metal is what's being oxidized. So, they're going to flow from high to low. So, that means when you're looking at your table J, if we find where zinc is here, the electrons are going to flow from zinc to copper. So they're going to go from zinc to copper. And since zinc is higher, it's more active, so they're going to go from the more active metal to the least active metal. So remember, at the anode, oxidation happens, and at the cathode, reduction happens. So here's an example of our voltaic cell. We have Zn plus 2 ions in solution here, and we have copper plus 2 ions in solution here. We have a piece of copper here, a piece of zinc here, and the electrons are going to flow from zinc to copper. So, the first cell is where your oxidation is going to happen, and this is where your anode is. The second cell is where your reduction is going to happen at the cathode. So what happens to the electrodes as the electrons flow? So the cathode, in this case copper, is going to increase in mass. And the anode is going to, which is going to be zinc, is going to decrease in mass because zinc is losing electrons and it's going to copper. So we lose electrons, and as we go across the wire, the electrons move, so that is going to change what happens, and that is going to allow for mass to increase at the cathode and decrease at the anode. So, why do voltaic cells have a salt bridge? The salt bridge allows for the flow of ions to prevent a buildup of charge at each electrode. So, positive ions flow to the cathode, negative ions flow to the anode. So, the positive ions are going to go to the cathode, and the negative ions are going to go to the anode through this salt bridge. So this thing can be neutral. So what happens when a salt bridge is removed? If the salt bridge is removed, the voltage will go to 0 because there's going to be a decrease in electron flow, and eventually the electrons are going to. An example, label the following: anode, cathode, where oxidation reduction takes place, and the direction of the electron flow. So we're going to label this tomorrow in class, and we're going to label this practice and this check your understanding. See you tomorrow.